Okay, good morning students. Myself Prakyati, working as assistant professor in Department of Electrical and Electronics Engineering in SJB Institute of Technology. So today I am going to explain time response analysis of a system. So as you all know that the time response is nothing but whichever the system which behaves, that is nothing but it is going to give an output from the input. Whatever the input it is going to take, and it is going to give some output, and the process is happening in between input and an output. All the reference we are going to take it as a time domain, that we call it as a time response. So you can see here, if the output of a control system for an input varies with respect to time, then it is called as time response of a control system. Okay, so the time response of a control system, you will be having a transient response and steady state response. So in this picture I am going to explain what you mean by transient response and what you mean by steady state response. You can see here, up to here we call it as a transient state, and after this we are going to take it as a steady state. By definition, see here, the response of a control system during the transient state is known as a transient response. Okay, what do you mean by transient state? Okay, so transient state is nothing but from the input, whenever it is reaches to the desired output, near to the desired output, up to that we call it as a transient state. So once the system reaches the steady state, steady state after completion of transient state, that we call it as a steady state. So overall response of a system C of t is nothing but the time taken during the transient response plus time taken during the steady state response. So that entire thing we call it as a total response of a system. Okay, so let us take the input signals. Okay, that is also very important. Unit step signal is the one of the type of an input we are going to take. U of t is equal to 1 whenever the t greater than or equal to 0. Apart from that, t less than 0, you are going to get the value 0. You can see in the response, at t is equal to 0, your output is 1, and up to infinity your u of t is 1 only. So if you take in the left hand side, that is negative end, t less than 0, the values is 0. Okay, so that we call it as a unit step signal. Then unit ramp signal, r of t is equal to t, t is greater than or equal to 0, that is equal to 0, the t is less than 0. So that representation we are going to do as r of t is equal to t into u of t. So whatever the instant, at 1 your output is 1 because that is t, the value is t only. At 2 your output is 2. Okay, 2 into u of t. So that is the meaning, means at time 1 its output is 1, 2 its output is 2, 3 its output is 3. So like this the response is going to happen, and the rest of the thing, negative side, it is 0 only. Then the parabolic input, that is t square by 2 whenever t greater than or equal to 0, and that is equal to 0 whenever t less than 0. So the representation of parabolic input is p of t is equal to t square by 2 into u of t. So at the value of t 0, entire thing is 0. So you can see here, at t is equal to 1, you are going to get 0.5. At t is equal to 2, you are going to get 2 means you are going to get 1. Exactly half of the value of t you are going to get till the infinity. But in the negative end, you are going to get the value 0. Okay. So this is how we are going to take the test inputs for any of the control system, for studying of any of the control system parameters. Okay, So these are all the responses which is not important. Only thing is what is the steady state, what is transient state, and one more thing which is not mentioned here, that is steady state error, that is ESS. That is nothing but steady state error. The difference between actual output and the desired output, we call it as a steady state error. That we call it as ESS. ESS is different for different test input. We can see that details in the next video. Thank you.